Hi, I'm Professor Jones, and in this video I'm going to go through how to estimate the minimal sample size needed when you are trying to construct a confidence interval and sigma is known. Okay, so I have this problem up here, and the reason why it is this type of problem where we're looking for the minimum sample size needed and not for a confidence interval is this question right here. So I always kind of zero in on the question, and it says, how many home prices does he need in order to do this within $5,000? And so the question here is how many? And so we're not interested, even though it's talking about this 90% confidence, we're not looking for a confidence interval. We don't have the necessary pieces to do that. We don't have an X bar for that, but we do know that we want to eventually construct that interval, and the question is, like, here's a margin of error, and then how many houses do I need to survey in order to get that a desired margin of error? So there's a few things that you can control when you're constructing a confidence interval to make it bigger or smaller, and that's talking about the width of the confidence interval. So sometimes you want that confidence interval to be pretty tight together. You want there to be a narrow interval, and sometimes you don't mind as much. But if you have a set margin of error, like how tight you want that interval, and there are a few things that you can control in order to keep it that tight. And one of those is the sample size. The other is how confident you are, but he says he wants to be 90% confident, so that is fixed here. So we're looking for N, the number of houses that need to be surveyed. So I have the margin of error formula for a confidence interval when sigma is known. Sigma is known here. It's given right here. It has to be known in this type of problem. You can't use this with the unknown with a t distribution. It's just impossible to have a normally distributed. You can't use a t sub c here because you would just have to know what n is in order to find t. And so you have to use a normal distribution and a sigma here for this case. So if you're wanting to know how many things you should survey if you don't have a sigma, you're going to have to figure out a way to estimate it in order to do this. Okay, so sigma is known, and so we're using this margin of error formula from a confidence interval when sigma is known. It uses a normal distribution, so a critical value of z sub c, and then a sigma, okay, over the square root of n. So this is the margin of error in a confidence interval. This is what you add and subtract on either side. Okay, and so we are given E, we're given C, so we can find our z sub c. We're given sigma, and what we're trying to find here is n. So it would be nice to have a formula where n is over here on the left side. And wonderfully enough, we have algebra, and so we can actually take this formula and manipulate it and solve it for n. I'm not going to show that right now. I'll just go ahead and give you that. But it can be derived from that margin of error formula. Okay, so all this is that I found here is this solved for n. Okay, so I'm using that margin of error formula and solving it for n. And so that's what we're asking here is, what is n? So that's what we're trying to find, and so we need these pieces, z sub c, sigma, and e. Okay. So z sub c comes from the confidence level, and typically there is a little chart that you should have that will tell you the confidence level and then the corresponding z sub c critical value. And I'll try to link something in the description below. You can find this with a normal distribution. You are looking at an area of 90% and then the corresponding, like centered around the mean, and then the corresponding z sub c values. But it's easier to use a table that just gives them to you outright. And so for the z sub c for 90%, you should get a critical value of 1.645. Okay, so that comes from just knowing where we need to be 90% confident and using a table to find the corresponding confidence critical value for that confidence level. sigma is given to us pretty plainly there. This is the population standard deviation. It's a very large one, so we're probably looking at needing a lot of houses for n. And then E is the margin of error, or like within what we want to be. And so this within 5,000 is telling us our margin of error. It'll end up being, like when you construct the confidence interval, it'll end up being 10,000 on either side total, okay, but 5,000 on either side, okay. All right, so these are the pieces and they just plug in, so I'll write that out. Use a dot for my multiplication there. And don't forget to square the whole thing. It's very tempting to forget that square at the end. So we do this division, multiplication, division, square the whole thing, and you should get 270.6. And so far in statistics, we've become very comfortable with these decimal numbers. So I've always talked about, like, if you get an average, it's okay to be a decimal. I know that we can't have like 0.2 people, but we can talk about an average of 0.2 people, okay? But here we are wanting to know how many we need to survey, how many houses we need to survey. I can't survey 0.6 houses. So the context here doesn't allow for that decimal point. And we need to do some rounding. And since this is a minimum sample size needed. And I would never want to go below that. I mean, excuse me, go below this because it's a minimum. So even if this was like 0.1 or 0.01, I'm still going to take that number and bump it up to the next nearest whole number so that I never have more than a 5,000 margin of error. So this, of course, rounds up to 271, but I just wanted to make it clear that even if this was a 0.1 or a 0.2, then we would still round it up to 271. So we need to survey 271 homes. All right, so we need to survey 271 homes in order to then come back with a confidence interval that's 90%, that's no larger than this 5,000 for the margin of error. Again, that's on either side of the X bar, okay? Hopefully this was helpful. If you're interested in more videos on this or other concepts in statistics, I have them on my channel. You can subscribe and check those other videos out. Like this one, it always helps me to get likes and subscribers to continue to make these videos. So I appreciate that, and I hope to see you again.